Bismillahirrahmanirrahim. We have discussed paging in previous lecture. So in this lecture, we will discuss our next topic, that is segmentation, which is a similar concept like paging with slight differences. Segments are also created of user programs the way pages are created. So in today's lecture, first topic that we are going to discuss is segmentation. What actually segmentation is and how they are created. So let's start our lecture. When a program is divided into chunks of unequal sizes, those chunks are known as segments. While pages were of equal sizes, as we discussed in previous lecture. So a process may have different segments of varying sizes, and they can be loaded anywhere in main memory. That means all the segments of a process need not to be in sequence when loaded in main memory. Every segment has instructions and or data, and there is no internal fragmentation in segments. But external fragmentation may be observed if a segment size may not match the size of the main memory partition. But this problem may be reduced if we use small size segments. Segments are visible to programmer because programmer designs the segments by dividing his program in different functions. While pages are not visible to programmer, segment table is also maintained by operating system, and every entry of segment table contains two information. The information include the starting physical address of that segment and the length of that segment. The length of the segment or size of the segment is required because segments are of varying lengths. And this is also required for the protection of different segments from segments of other processes in main memory. It is advised for programmer to keep the size of segments small. That means functions in a program need to be made of small sizes. Now we are going to discuss address translation using segmentation. How logical to physical address translation happens in segmentation. When a process starts execution, the CPU register is loaded with the starting physical address of the process segment table. The logical address of a single instruction within the segment is made up of to information as mentioned previously. The information include the respective segment number and the offset within that segment. This constitutes the logical address. Offset again here represents the relative address or distance of instruction from start of the segment. CPU then searches the segment table to obtain the starting physical address of the segment and its respective size. The respective physical address is generated by adding the offset with the starting physical address of the segment. The offset of a single instruction is then compared with the size of the segment to ensure if the instruction resides within the range of the segment or not. This is done for the protection purposes to ensure that the reference instruction is within the logical address space of a specific segment. The diagrammatic representation of the translation process is now in front of you. CPU generates the logical address. Here is the logical address consisting of segment number and offset within the segment. The segment number is indexed with segment table to obtain the starting physical address of that segment along with its size. So here segment table is searched out to find the starting physical address of this particular segment and its respective size. Once the size is obtained, then this offset gets compared with this size to see if this instruction is residing in this particular segment. If it is part of this particular segment, so the offset then gets added with the starting physical address of this segment in order to obtain the actual physical address of the instruction in main memory. But if the offset is not within the range of the segment, so an interrupt is generated. If it is not within the range, an interrupt is generated for operating system to inform that it is an illegal instruction that need to be aborted.
(16 bits) logical address is then translated in 16 bits physical address. Here you can see this is the 16 bits logical address, which is ultimately translated into this 16 bits physical address. You can see the starting 4 bits here in logical address represents the segment number, while the remaining of this 12 bits within logical address represents the offset. This segment number is indexed with segment table here. in order to get the starting address of the segment as well as its size. So this is the starting address and that shows its total size or length. So the offset here, this is the offset part, this one. So this offset is then compared with the size of the segment. So this offset is if within the range of this length. So it is considered as a legal or valid instruction. So this offset is added with the starting physical address of the segment. That means it is added with the base address or the contents of base registers to get the physical address of a single instruction. So this is the physical address of actually a single instruction. The instruction that we were referring here, the segment, and it is again in 16 bits. So 16 bits logical address is ultimately translated into 16 bits physical address. But here you can see it is different way of translation than paging. Paging was simple, where the page number was taken from page table and it was linked with the offset to get the physical address. But for segmentation, we first need to find the size of the segment, because every segment is not of equal size. Segments are of varying length. So we need to first find its size and then compare the segment number with its size. If the particular instruction is within that segment size, then that instruction is translated into physical address. So the translation process for paging and segmentation is slightly different due to the varying size of segments, while pages are all of same sizes. So I hope this translation process will be clear to you now, how it is performed in paging and how the translation is performed in segmentation. Next topic of discussion is to make the comparison between paging and segmentation. This is the last topic of discussion in this chapter. We have already discussed what paging is and already discussed what segmentation is. So now we have to make the comparison. What is the difference between these two concepts? So let's see how we can compare these two techniques.
Some comparisons are made between paging and segmentation. You all must know that segments and page both are formed from a user program or a process. So the first major similarity among both is that they are made up of processes, or in other words, user tasks. But since segmentation is done by a user or programmer, so the hardware required for the address translation in segmentation is more complicated as compared to paging, because user has freedom to decide the size of his or her programs. So the address translation, as we discussed in previous slides, gets more complicated task for the operating system, as user segment size may vary time to time. But since pages are made up of user tasks, and this is done by operating system itself, so the address translation in paging is simple as compared to segmentation. You might have noticed the differences in the address translation mechanism of both the techniques. Address translation of paging was quite simple, while the address translation of segmentation is little tough, as we have to also compare the size of offset or the offset with the size of segment table to ensure that this is a valid instruction. Paging is thus not visible to the programmer, but segmentation is. As we have already said, user makes segments himself. Another difference between the two is that segmentation has external fragmentation, as we have already discussed while we were discussing segmentation, while pages generate only small amount of internal fragmentation. We have already discussed how internal fragmentation can be generated in paging in our previous lecture. So segmentation suffers from external fragmentation, while paging may generate very small amount of internal fragmentation. Segmentation actually is the treasure for programmer to organize his programs. So protection is provided in segments in shape of the size, as we store the size or length of every segment in every segment table. While protection in paging is provided using valid and invalid bits. We have already discussed what is valid and invalid bits in previous lecture while we were discussing paging. So protection is required both in paging as well as segmentation. In case of segmentation, we provide the size or length of every segment for comparison with every instruction in order to see if the instruction is valid instruction or an illegal instruction. While with paging, there is a valid invalid bit with every page. In order to confirm a reference page is a legal page or an illegal page. While you also know that segments and pages are made up of user task, but segmentation is of varying sizes while paging is of same sizes. So this is all the comparison that we make between the two.
Here we come to the end of chapter 7, that is virtual memory management. In this chapter, we discussed two techniques for organizing user processes in memory. User processes are loaded from virtual memory to main memory, and how they are organized. The techniques were paging and segmentation. Page divides user process in equal sizes, while segments are made up of varying sizes. Both are made from user tasks or user processes. We then find out how user processes in segments and pages can be translated to actual real physical addresses. The translation process or the translation mechanism for paging and segmentation have been discussed in this lecture, and there is a slight difference between the translation mechanism of both the techniques. We also have learned how protection can be provided on pages and segments. So I hope you have understood this concept. We will discuss some more concepts related to virtual memory in next chapter. That is all for now.
I thank you all.